All right, resampling is something that's used quite a bit. And it is the method that consists of drawing repeated samples from the original data samples. And that sounds kind of like, how in the world do you do that? You do it one time, you've got your information. How is it possible to keep pulling information from that one trial or that one experiment? Okay, so I'm going to show you because it's actually pretty nifty. Okay, so resample the data in example 1 using a simulation. Use the mean yield of the new control and treatment groups to calculate the difference of the means. Okay, so this is what they're wanting. Let me show you what they're asking for. Okay, so your control group. This is what we had before. Okay, this is what we were talking about in that first example. Here's what we had in our control group. This is our treatment group. Now this is how they resample. They take each one of these numbers and they assign it a number. So this is number 1, 2, 3, that's what shows here. 1, 2, 3, 4, 5, 6, 7, 9, 10, up to 20. So each one of these numbers gets a number. Then what they do is they pick numbers at random. Okay? And they just throw them in there and put them in a different order. Okay? So for example, they picked, this is the random order of numbers that they picked, and this is how it turns out. And again, this is the original group. This is when they redid it. So this is the new control group. This is the new treatment group. You would think that they would only mix up, well, no, that doesn't make any sense either. Anyway, sorry, my mind just went someplace else. Okay, so that is resampling, and then they take the average of the new control group. They take the average of the new treatment group. Okay, and so in this particular experiment, when you take the averages of the two, they only got 0.08 this time. Before it was at 0.32. And so this is less than the experimental difference found in example 1 by quite a bit. It was 0.32, right? Yeah. Starting to get my lessons crossed. So it seems to be less effective. Okay. So making inferences about a treatment, I'm going to use my book for some of this. Okay. So, to conclude that the treatment in example 1 is responsible for the difference in yield, you need to analyze this hypothesis. So say that this is what the people say. And when I say the people, maybe it's farmers, I don't know, it's probably not the company, okay? But this is what they're saying. The soil nutrient has no effect on the yield of the cherry tomato plants. Okay, this is the hypothesis. And we need to look at the data to see if this hypothesis is correct. So we do that resampling that I just showed you. Say they do it 200 times. And we're going to compare the experimental difference of 0.32 from example 1 with the resampling differences. Okay? So what they did is they did that resampling 200 times. And they took every single one of their answers and they put it into this histogram. And if you look, I think this is very, very interesting. It is normally distributed, okay? But the first experiment you have to remember is at 0.32. So what is it that we can conclude from that? And this is what the book says. I'm just going to read this. Sorry, I've had a hard time trying to come up with a better way of saying it, and I don't know that I can. So it says, note that the hypothesis assumes that the difference of the mean yield is 0, meaning take it or leave it. It doesn't do anything to the cherry tomatoes. The experimental difference of 0.32 however, lies close to the right tail. From the graph, there are about 5 to 10 values out of the 200, okay, right here, that are greater than 0.32. So they still had some that were quite a bit bigger. So this over here at most is 5% of the values. And then it goes on to talk a little bit about how a lot of the values lie in 90% of this, but ultimately the conclusion that we come up with is that it is unlikely to get a difference this large when you assume that the difference is 0, suggesting the control group and the treatment group do differ. So, what we can conclude from this is that the hypothesis is most likely false. 5% is a lot when you're talking about the center being at 0. I know that that's kind of hard to wrap your brain around, but it says, so the soil nutrient does have an effect on the yield of cherry tomato plants because the mean difference is positive. The treatment increases the yield. So another way to look at this too is if you're looking at from 0 this way, there's a total of 200 experiments. When they do it again, resamplings, that's what I'm trying to say. And there's actually 117 on this side, which shows that there's increasing. And so in this case, it does make a difference. Okay, I know it's weird, but that's it. That's what I have. These lessons have been very short. Some have been easier than others. And like I said, a lot of you are probably already done with all of this. That's great, but I miss you. I wish I could see you again next year. I don't know where my room's going to be. It's probably not going to be this one, but make sure you stop by and you say hi to me. Here's your assignment. Here are cherry tomatoes. We'll see you. Again, if you have questions, let me know.